What you see here are two neurons that want to chat and gossip. Those branching structures that seem to be searching for something are dendrites. The function of this part of the nerve cell is to transmit information. What they are looking for is a connection, to connect to another cell and communicate. The union between both cells that is forming is what we know as a synapse. The human brain has millions of neurons that communicate with each other through synapses, in which neurons exchange electrical impulses or neurotransmitters. The network of these connections makes us who we are. This process has happened millions of times in your brain, allowing us to remember that birds fly, fire burns, trees grow, and the sky is blue. It also allows us to learn to solve differential equations and recite the most sublime poetry. In the past, we thought of our brain as something fixed with few changes throughout life. You've probably heard that we are born with the neurons we will have for life, that children are sponges for learning, but you can't teach an old dog new tricks. While these were beliefs for many years, modern scientific advances have shown that this is not the case. The brain evolves throughout our lives and adapts to our circumstances. It all has to do with a word: neuroplasticity. In fact, while you watched these two neurons form connections, your neurons formed connections about how neurons form connections. Inception. Neuroplasticity, or brain plasticity, is a process that involves adaptive structural and functional changes in the brain. It is defined as the ability of the nervous system to change its activity in response to intrinsic or extrinsic stimuli by reorganizing its structure, functions, or connections. Stimuli include new experiences, learning, practices, or even injuries. Learning languages is so relevant to cognitive function that it has its own section. As you may have noticed, I am passionate about talking about the wonderful machine that is the brain. It is our window to the world. Many of the studies I share with you stem from a curiosity about how to keep my brain healthy. Science tells us that one of the best ways is by learning languages, and the best app for learning languages is Babbel. You don't have to go out looking for teachers. You already have them on your phone. Research shows that learning a second language strengthens the brain by increasing gray matter volume and white matter integrity. All languages have this positive effect, and Babbel offers 14 different languages for you to choose the one you like best. There is evidence that being bilingual protects against cognitive aging. Babbel uses a proven method that allows you to start speaking a new language in just 3 weeks. Unlike other apps, Babbel has lessons designed by over 100 linguists and native speakers. Learning languages with Babbel will help improve your memory, attention, and concentration. Moreover, speaking different languages connects you with cultures and people around the world. Below, I'll leave a link where you can get a 60% discount to start taking care of your cognitive function today. If you subscribe through the link, you can also take advantage of a 20-day money-back guarantee. While you're at it, tell me which language you're interested in learning with Babbel, and why. There are several mechanisms through which neuroplasticity manifests. For a long time, it was believed that we were born with a fixed number of neurons, and that we couldn't generate new ones. However, recent research has shown that some areas of the brain can generate new neurons in a process called neurogenesis. This process is more prominent during childhood, but can occur even in adulthood, although at a lower rate. Throughout our lives, but especially when we are young, our brain continuously forms and eliminates synapses. There are two processes related to this mechanism. The first is synaptogenesis. Every time we learn something new or acquire new experiences, neurons form new connections with each other, reinforcing the information and consolidating it in memory. The other process is known as synaptic pruning, in which synaptic connections that are not frequently used can weaken and eventually be eliminated. Although this might sound bad, it is actually beneficial because it allows the brain to conserve resources and focus on connections that are truly useful. Imagine a 3-year-old girl remembering 100% of Frozen's dialogues for the rest of her life. In our brain, the premise of use it or lose it applies. Another example is when we study 10 minutes before an exam. Yes, the information is useful for passing, but later we realize we don't remember anything as if we hadn't learned because there was no real reinforcement, and our brain simply discarded the information. In addition to forming and eliminating synapses, the brain can also make existing synapses stronger or weaker. This is a crucial process for learning and memory, which gives rise to the saying, "Practice makes perfect." When you practice a skill, the synapses involved in that skill strengthen, helping you improve. When synapses strengthen, the process is known as long-term potentiation, LTP, and when synapses weaken, it is known as long-term depression, LTD. Finally, there is cortical reorganization. This happens in response to injury or brain damage and allows the brain to reorganize itself. Functions that used to be performed by a now damaged part of the brain can be transferred to another part of the brain. For example, it has been observed that when people lose their sight, the section of the brain that used to process visual information begins to process other types of information, such as touch or sound, with a larger processing area. These individuals develop sharper hearing that allows them to navigate the world and more precise touch. Although this sounds like an extreme example of neuroplasticity, our brain has proven to be much more adaptable than we thought, which is why rehabilitation therapies can help people recover from brain injuries or improve their cognitive skills. Today, we know that neuroplasticity doesn't only occur in the early years of development, but continues throughout life, and the brain can generate new neurons even in adulthood. By understanding how neurogenesis works, we can improve the way we learn and keep our brains healthy throughout our lives. Yes, age affects the rate of plasticity in our brain, but the brain's ability to change is always there. The difference between plastic brains that form new connections and those in which connections weaken and are lost lies in our habits. Children are sponges for learning because they are constantly discovering the world, dedicated to learning 24/7. Of course, biology helps them, but even in children, it has been shown that without stimulation, the brain also atrophies. Therefore, our environment and habits are very relevant to our biology. In youth, our academic formation keeps us constantly learning, challenging our brain to process new information, and forming new synapses. At this stage, we are also very active and social, practicing new sports and constantly meeting new people. The problem is that as we reach adulthood, we lose this lifestyle that promotes the formation and maintenance of synapses and new connections. Since we are no longer in school, no one asks us to analyze or remember new data. As adults, our routine might prevent us from exercising or meeting new people, and we may not have time for a hobby like learning origami or playing the guitar. Moreover, chronic stress, lack of sleep, and alcohol consumption affect our brain, especially areas related to cognition, such as memory and learning. Alcohol, in particular, is very harmful as it has been shown to damage brain structure. We'll talk more about the impact of alcohol on health in another video. With age, our habits change, and we tend to challenge our brains less, socialize less, become less active, stop exercising, possibly drink more alcohol, become more stressed, and sleep worse. This lifestyle contributes to the deterioration of our cognitive functions. The good news is that all these are things we can change. Your brain is adaptable, and its nature is plasticity. Your brain is ready to change. The first and basic thing to have a healthy brain is to sleep. Sleep is extremely important. Many repair processes and memory consolidation occur during our rest hours. A brain that doesn't get enough rest is doomed to deteriorate. Additionally, eating a balanced diet, including foods rich in omega-3 like fish and antioxidants like fruits and vegetables, is especially good for our brain, as is trying to reduce stress levels and stopping alcohol consumption. All these actions are things your brain will thank you for. Now, we must challenge our brain. The brain is like a muscle. If you don't use it, it atrophies. We must become curious beings interested in the world throughout our lives, forever students. And here, everyone has their interests. If you are interested in learning the 10-15 Pokemon, that's great. Your brain doesn't care if you're learning the world's capitals or who that Pokemon is. What matters is that it now has to store that new information. Learning to play an instrument is also excellent for the brain because it integrates multiple areas when learning. We have to use hearing, motor coordination, touch, sight, and memory. It's a real challenge. I know Netflix is super entertaining, and social media like TikTok and Instagram are practically addictive. But spending hours in front of a screen that doesn't demand any interaction from our brain is not the best for our cognitive future. Our brain adapts and grows in response to new experiences. Go outside, take a different route to work, read a new book, meet new people, see new places, new sidewalks, new plants, new dogs, new smells, new sounds. And no, I don't just mean traveling. You don't need to travel to do this. We can do it on our block by being more curious, more observant, more present, doing everything with intention, asking the person in line what they do, what they like to eat, chatting with them. Also, practice a new hobby or dust off that forgotten hobby. When we practice a skill or habit frequently and consistently, we strengthen the neural connections associated with that skill or habit. This makes it increasingly easier and more natural to perform the skill or follow the habit over time. Setting challenges is also very important as it challenges our brain and stimulates neuroplasticity by forcing the brain to adapt to new situations. This can include working to solve a very complex problem, learning a skill we consider difficult, or facing unknown situations. Remember to add variety to your learning. Variety in learning can stimulate the brain in new ways and foster neuroplasticity. This can include learning about a topic from different perspectives, using different techniques, or even varying the place or time of study. Have you ever noticed that children are taught something as basic as colors in 1,000 ways? Repeat the R in red, eat red apples, draw with red crayons, write in red cursive, dress in red, play identifying red things, smell red things. Thousands of learning methods are used in our early developmental years, but when we are adults, we stop using them and stick only to reading and writing. For example, if you're trying to learn anatomy, imagine the difference it would make to buy Play-Doh and play at forming each section of the digestive system. I'm sure it would be better than just writing out the esophagus and intestines. Be creative and treat your learning as you would for a child. Another great method is meditation. Meditation can promote neuroplasticity by increasing concentration, calmness, and present awareness. It has also been shown to be beneficial for reducing stress, which is good for our brain and overall health. There are thousands of techniques for meditation. My recommendation is to find one that works for you. There are even guided meditations for beginners. The important thing is not to get frustrated or give up if the technique you are using doesn't suit you. Move on to the next one. And don't forget the importance of being physically active. Physical activity has been shown to promote neuroplasticity. This includes both regular exercise like walking, running, or doing yoga, and activities that require coordination and learning, like dancing or swimming. The most important thing is to move. Find a sport you enjoy doing. There is something for everyone. It's not just about weights, exercise, the gym, or running. It can also be playing soccer, climbing, playing tennis, playing hide and seek, or tag. Find an activity you enjoy and want to repeat consistently, and you'll see how your brain thanks you. Neuroplasticity is an active area of neuroscience research. There are still many processes to discover to understand the wonderful machine that is our brain.